Hello everyone. This presentation today is about breed-based ontology and data management. My name is Chris Simões. I'm part of Miller Lab team at Boyce Thompson Institute. Breed-based is organized as a digital ecosystem, and the main idea here is cover all steps in a breeding program, including how to design your trial, how to manage germplasm, field trials, and so on, how to store data from field evaluation and also genotyping. There are some tools for analysis, and then make selection in field. Finding a trait is an important step before storing your data. To find your trait, you have to go to search and then traits, select the ontology you want to search on, and then write in the name or part of the name that the trait you want to search, and then click on search. And after that, you will have a list of traits or with similar names you have typed before, and then you can click in the name of the trait you want to see more details. In this case, I was searching for dry matter content, and I found this one, dry matter visual rating 1 to 3. And here I can see the term ID, the term name, and definition. It is a visual rating for dry matter content of fresh cassava root, and the numbers available are 1, 2, or 3. There is no synonyms for this trait, and here in this trait property there is a very important point, which is trait default value 1, 2, or 3. It means only those values are allowed to be stored in the database. So if you go to the field and collect data for dry matter visual rating, and you type, for example, 11 rather than 1, and try to store 11, it's not allowed. You have an error message saying, oh, there is something wrong with your number, and please check it again and try to store. So this is a very important filter in data collection. However, if you do not find a trait that you want to work on in field, you can post-compose a new trait. And post-compose a new trait means there are already some traits, they are stored in breed-based, but you want to combine different attributes or objects to your trait and creating a new combination to store the data. And how to do that? You can go to Analyze, and there is an option here named Compose a New Trait. Requesting a new trait. In the previous case, I was talking about how to post-compose a new trait if you have already some traits and some options stored in breed-based. However, if you are not seeing a trait on an option that you want to see there is a way to request a new trait, and this is the website where you have to go. And in this website, you can select which ontology are you working on: cassava, sweet potato, musa, banana, yam, or potato, and fill the other options, and then select a new term or update term or synonym, and then submit your request. In this case here, it is submitted to curation. So after that, we will get an email, and also curators will have an email about this new request, and then after validation, it will be available in breed-based. It's the same way. If you are not so confident in how to do that, please let me know and send to me an email. And traits and quality control. After storing your data in Gridbase and you want to check how your data is in your trial, you can go to your trial and access phenotype summary and statistics. And here you will see a list of traits that your trial has, and there are some terms to check the quality. For example, the mean, minimum, maximum, standard deviation, coefficient of variation, percentage of missing data. And also you can click in this histogram, and in the histogram you are able to check the data per replication. For example, I'm selecting this part of the histogram, and it is showing the first replication and then also the second replication. You can see here the difference between plots in the same trial. Also, in the trial details page, there is a box there named Analysis Tools, and here you have trait heritability, and you can see a list of traits, and you can check the genotypic variance, environmental variance, residual variance, and heritability for each trait you have. Also, you can use heritability as a quality control or quality indicator. Creating tissue sample. Tissue sample is important to work with NIRS, for example. Also, there are other tools you can use tissue sample, but in this case I'm interested to show tissue sample for NIRS. Tissue sample can be created here. You can go to Manage and select Tissue Sample, and then create tissue sample for field trials. Trials are organized in this way. Trials have plot. Inside the plot you have plant, and then tissue sample. And following this workflow, selecting your trial, you want to add some tissue sample and how many plants per plot you want to add. If your trial does not have plant entries yet, you can add it here, and then add tissue sample. In this case, I want to evaluate for the same route two different preparation, in this case boiled and raw, for the same route, just two different slices. So I'm making two tissue samples, and after clicking on submit you have this message: successfully created tissue sample entries. And then to store NIRS data, you can go to Manage NIRS and find your template, and what you need is a tissue sample name or sample name here and the wavelengths. I'm showing a file with tissue sample names and wavelengths and some spectrum data. The file must be in CSV format. That's very important. Storing progress of NIRS data at working package 3. First thing is upload accessions name using a list or a text file. Then add the breeding program, for example UAC Benin. Also add in trials location such as DASA. The third thing is add field trials To do that, you can use add trial in breedbase, or for example, using the right file format and then upload to the database. And finally, you'll be able to load your NIRS data. There are already 4283 NIRS spectra uploaded in breedbase by working package 3. 249 are from CIRAD in YAMBase, 160 by CIAT in Cassava Base, 982 by NACRI in Cassava Base as well, and 2892 by SIP in Sweet Potato Base. Some challenges were faced during this process, such as linking the trial data with the NIRS spectra, which means create a tissue sample and link this tissue sample with the spectrum, and also putting the file in the right format. Next step is each partner should appoint a data manager to accelerate the uploading process. Here is an example of quality traits in Cassava Base. At CIAT, in 2020, there are 15 of 64 trials being evaluated for cooking quality. Pollination and harvesting is ongoing. Here, you can see a snapshot in Cassava Base from CIAT, where it's possible to check the data quality in this histogram for a quality trait, and also it's possible to see many different post-composed traits with different times and also different sample prep. In Cassava Base, for instance, 9 new variables were defined to describe quality traits of boiled cassava. And with those 9 variables, you can combine with age of the plants and also different boiling times, post-composing new traits. Post-composing new traits for quality traits, you can select variables or trait in this box, then selecting, for instance, boiling times, and also combine with the plant age. Here we have a template to upload post-composed traits for a trial. The trial is stored in Cassava Base with 36 genotype, and there are 38 post-composed traits associated to this template. However, in this slide, I am showing only 5 different post-composed traits. The trait is changing weight after boiling computation percentage in different boiling time. Here is only 10 minutes, here is with 20 minutes, 30 minutes, 40 minutes, and 50 minutes. And with this template, you can fill each column with the right number after your evaluation, and then store in breedbase, or more specifically in Cassava Base. Here is the template with all information you need to upload in Cassava Base or in breedbase. The first column is the plot name, and here there are the traits or post-composed traits with all numbers from your evaluation. After that, you can go to Cassava Base and upload back your evaluation. Checking the result for your quality trait in Cassava Base, like we talked before, you can go to the field trial details page and check the mean, minimum, maximum, standard deviation, coefficient of variation, count, percentage of missing data, and also see the histogram. And also you can go to Analyze tool and check the heritability. From 2020, there are 4 trials already uploaded in Cassava base with quality traits, one with 434 genotypes and 5 variables and 1 harvest, the second with 377 genotypes with 5 variables and 1 harvest, the third with 36 genotypes and 9 variables and 4 harvest, and fourth with 28 genotypes and 9 variables and 2 harvest. Integrating data from trained sensory panel of working package 2 in BreedBase. In this first table, you can see the data in the format available from BreedBase with plot name, plot ID, accession name, and so on. In the second table, the data is from sensory panel, specific per panelist. You can see the identification of the panelist, and with sensory attributes. And after validating this format, it will be available in BreedBase. So breeders will be able to search for sensory profiles for varieties. Sensory trait dictionary for the crop ontology was developed, describing trait name, method, and scale. And when combining a trait name with a method and scale, we have variable name. For instance, boiled root surface yellowness combined with method appearance, method, and scale yellowness, scale 0 to 10, we have this variable name, boiled cassava surface yellowness, scale 0 to 10, which is the variable used to collect the data in BreedBase, for instance. Currently, sensory trials are using specialty trials to make sensory evaluation. Is it the best way to do, or should BreedBase include a new model for sensory panel? Or should food scientists use BreedBase as their lab book for trained sensory panel, and making all information available in the same place for breeders and sensory panelists and anyone that want to search the data? Thank you very much.